So here's my hypothesis regarding large language models. Currently, the context size of each of the large language models are increasing. So initially, when the 7 billion parameter models were released, they had maybe 2K context, 4K context, and so on. Now we have 8K, 16K, and 32K. So recently, the Mistral 7B had a 32K context length on its base model, and the Instruct model had a 16K context length. So that is the first fact. First fact is context sizes are increasing even for smaller sized models. First fact. Second fact. Second fact is that there are a lot of innovations that are going on, especially in the LLM space. So there is flash attention, there is rope, there is Gallo. There are different methodologies that are used to fine tune and optimize these algorithms. So they're becoming faster and they're becoming better. Okay, and there are new file formats like gguf, all of this. Ggml was there, now it's gguf, which they use. That's the file format, or xllama. So there are different file formats which are optimized for running these models faster, better. So that's the second part. Third part, vector databases may become, so before I get to vector database, third part is that the overall large language model that exists today, right, its speed is also increasing because again there's innovation in the algorithm, so latency. So eventually we'll be able to run most large language models locally, right? So these are like three main facts. And finally, and the final fact is and because it's becoming faster, we can also infer that the costs are also going down. Just like OpenAI API, the cost per million tokens of OpenAI has consistently reduced. It's been halved. It's been become 1/10, 1/15. It's continuously cut down because there's more compute, because Nvidia is making a lot of compute, and now more people are using the compute, and it's getting cheaper. So overall, from these hypotheses, we can say that large language models will become bigger and bigger, faster and faster and better when compared to technologies like vector databases. Vector databases now have only two, three innovations. Like you have Colbert on one side, and you have a few, which is one of the latest innovations, Colbert, right? And the other one is basically your normal vector database. Just take a small chunk, vectorize it, use a sentence transformer, use a transformer, get an embedding, generate an embedding, and use that embedding to retrieve and do retrieval augmented generation. So RAG will always exist because you will always have GBs and GBs of data. But for the specific purpose that I am looking at, I do not think I might need RAG to that extent. And I can emulate the same thing with just long context models. So if I just have long context on smaller models at faster times running locally, I think that's the exact use case that I have. So I think I do not need to use RAG or any complicated backend for this. So if I'm trying to productionize this, I will try and make it in a way where I can just use long context lengths, like just have very good prompt engineering and basically just use a Python script to exchange prompts here and there and just change up prompts dynamically when it's needed. That's about it. So this is my hypothesis, and I believe that RAG is on its way out for most small or medium context applications. Only for the largest context applications, RAG will still be very important. Uh, yeah, that's basically what I think.